Hi! Today I'm going to show you how to solve problem 30 from the 2019 Math Kangaroo, grades 5 to 6. Here's the problem. Zev has two machines. One makes one white token into 4 red tokens, while the other makes one red token into 3 white tokens. Zev starts with 4 white tokens. After exactly 11 exchanges, he has 31 tokens. How many of these are red? So there's two machines. If we start with one white token, and I can't write with white on this board, so I'll just do a black circle and it'll be white inside. Well, we could put this into some box here, and this is our first machine. And what we'll get from it is 4 red tokens. Or we could take a red token and use a different color. And then it's going to give us 3 white tokens. So these are the two machines. These are the two things that we are capable of doing with the tokens. And Zev is going to start out with 4 white tokens. Okay, so if we can figure out how many times each machine is used, we can figure out how many get added and removed to the red tokens, and then we can figure out the total number because we know what happens to red tokens for each machine. So we know that 11 exchanges are made. So let's define some variables. So let's say machine 1, that's going to be, we can call the variable, let's say O for 1. So O is number of times machine 1 is used. And then we can have a variable T, which stands for machine 2. And T is going to be the number of times So we have two variables, and immediately looking at the problem, there's exactly 11 exchanges, and each exchange is either machine 1 or machine 2. So we know that T and O sum to 11, because that's the total number of exchanges. We also know that there are 31 tokens at the end. And in each machine, you're taking one and getting something else after that. But we can also think of it as just adding a few, because although we're replacing it with different colored tokens, if we're looking at just the total number of tokens, it doesn't really matter what the color is. So we can look at this as taking away 1 token and getting 3. So if we're taking away 1 and getting 3, here in machine 2, we get plus 2 tokens. And in machine 1, every time we use it, well, we take away 1 and we get 4, so we have plus 3 tokens, total tokens. So if we want to look at the number of tokens we gain and that will be ending in being 31? Well, we have the 4 we start with, and then we're going to add 2 every time we use machine 2. So it'll be 2 times t, which is the number of times we use machine 2, plus 3 times O, because we get 3 every time we use machine 1, and this gives us 31. So we now have 2 equations with 2 unknowns, and we can solve these equations to figure out how many times each machine is used. So let's substitute for t now. So I'll rewrite this equation here. We have t plus O is 11. Well, let's subtract O from each side, and we can do that because we're doing the same operation to both sides. That's allowed. So we'll have t plus O minus O. Well, if we add and subtract the same thing, then that's 0, so we'll just have t. And on the other side, we'll have 11 minus O, because we're subtracting O to both sides. And in the second equation here, we have a t. But we know that t is the same thing as 11 minus O. So we can choose to put in 11 minus O whenever we see a t. So now we have 4 plus 2 times 11 minus O, which is t, right there, plus 3O equals 31. And this is an O, not a 0. Okay. So now we have an equation. It's just in terms of O here. So we can expand here, and then we can solve for O. So let's expand first. We have 4 plus 2 times 11, that's 22, minus 2 times O, plus 3 times O is 31. If we add like terms together, we have 26 here, plus O equals 31. Let's subtract 26 from both sides. That way we'll just have the O here. So we have plus 26 minus 26, that's 0, plus O leaves just O equals 31 minus 26, which is 5. So now we know that O is 5, and we know that T is 11 minus O. And we now know that this is equal to 11 minus 5 because O is 5. And so that gives us 6. So O is 5 and T is 6. And now we know how many times we're using each machine. So now let's not look at the number of tokens we're getting through each machine. Let's look at what happens to our red tokens, because we're looking at how many tokens are red. The red tokens is what we care about here. So in machine 1, we start with 0 and we end up with 4. So what we have here is plus 4 red tokens. And here we start with 1 and end up with 0. So we're going to have minus 1 red token. So how many times are we using machine 1? O times, and O is equal to 5. So we know that we're going to add 4 red tokens 5 times. So we have 4 times 5, because 4 red tokens we're getting through machine 1 times the 5 times we use it. And then to that, we're going to have to add whatever we get through here, and that's going to be the 6 times we use this machine. T is 6. We're going to use this 6 times the -1 red tokens we get each time. So that's going to be 6 times -1. And this number here, we also have to add whatever we start with, but we don't start with any red tokens. So this is going to be the expression for the number of red tokens. That we have at the end. And that's going to be equal to, we have 4 times 5, that's 20, minus 6. That gives 14 equals number of red tokens. And that's what we're looking for, the number of the red tokens. The problem asks us how many of those tokens are red at the end, and so the answer is 14. Thank you.